All right, guys, if you look at your review, all right, there are 9 total questions on your test, but one of them is a graphing one, so it's going to have all this stuff. Everything else is just one of each. So you're going to have one of these zeros. Here are the zeros. Give me the polynomial. What is important with this? First of all, if you have a complex, right, if you have a complex zero, which means it has an I in it, right, a plus bi, or you have an irrational root, so square root of 3, negative square root of 5, whatever. You have to account for the opposite. So you're going to have conjugates for both of those. If you have just a regular root of x equals 7 or something like that, you don't have 7 and negative 7. But if you have a complex root, like negative 3 plus 7i, you also have to have negative 3 minus 7i. If you have the square root of 3, you also need to account for the negative square root of 3. Remember, when you multiply everything together, your polynomial should not have any i's in it and no square roots. So if it does, you should go back and be like, oh, wait, did I forget to do something? You also have to have f of x, g of x, h of x, something like that in the front of your answer. All right, everybody with me? You're not going to have ginormous numbers. If you do get ginormous numbers, then you need to go back and look and see, like, whoops, not great. You will have one of these. You guys are perfectly fine with factoring. You're perfectly fine with finding the zeros. What does x equal? It's the irreducible over the reals versus the rationals that gives you a tough time. So if you had something like this, let's just say you had x minus 3, x squared plus 9, and x squared minus the square root of 11, all right? These are my 3. When I factor, this is what I get. Tell me, when I set these equal to 0, tell me what kind of answers am I going to get? What kind of an answer am I going to get here for x minus 3 equals 0? It's going to be real and what? Real and rational. That's going to be real and pretty, correct? What am I going to get here when I have x squared plus 9? Set it equal to 0. X squared plus 9. You move 9 to the other side, it becomes negative. When you take the square root of a negative number, it becomes imaginary, not real. Good. And then what do you get here with x squared minus the square root of 11? Should be just 11, I'm sorry. Like this. In my mind, I wanted it to be 11. What do you get here? It's real, but what? Not rational. It's irrational. It's real and irrational. What does irrational mean when I think of like numbers? It's not pretty. When you guys think about rational versus irrational, if I said to you, where is x equals 3 on a graph, could you put your finger there? Yes. If I said to you, where is x equals the square root of 11? Do you know about where it is? Yes. Do you know exactly where it is? No. So if the question asks irreducible over the rationals, right? Break down everything that is rational. What would you write for irreducible over the rationals? X minus 3. That's the only one. And then what are the other two going to do? They're going to stay just like that. Why? Because one is imaginary and one is what? Irrational. If it says irreducible over the reals, what do you break down? The stuff that's what? The stuff that's real. So x minus 3, that's a real number. X squared plus 9 is not real. X squared minus 11, what would that break down into? X plus root 11 and x minus root 11. Do you guys understand that? You're totally fine. If I said write it completely factored, every single one of you could write that. If I said complete, that's one step before you write your parentheses. You'd have x minus 3. What would x squared plus 9 be? Completely factored. X plus 3i x minus 3i, and then you guys would have your x plus root 11 and x minus root 11. It's these two, for whatever reason, that give you guys trouble. But you all can handle complete. You can handle finding the zeros, because if you go one step ahead, what does your x equal? X equals 3 here. X equals plus minus 3i. And x equals plus minus root 11. Yes, ma'am?
So would it have a root or not, the 11? Because in the first one it didn't have a root.
Because it's not rational.
Oh,
If it says over the rationals, then you don't break it down, because square root of 11 is not a rational number.
so in the real it's already broken down.
The reals, the square root of 11 is a real number. It's just not pretty. Tamara, does that kind of
I think so.
a little bit? Okay. All right. Do you guys have any other questions on the first page? Yes.
So for the first one, when you do a conjugate of the negative one plus 3i, it's the sign in the middle that changes, but when you put it into the...
Let me show you why. Okay, look. If I have x equals, say, negative 1 plus 2i, right? Hold on. Let me write it up top here. I understand why this is confusing, but just mathematically, if you guys see it, I think it might make sense. So if I have x equals negative 1 plus 3i, I also have x equals negative 1 minus 3i, correct? Okay, so when you take this root that is negative and you move it to the other side, it becomes what? Positive. So you have x, it's plus, right? So plus a negative, so it's going to be x plus... I'm not even going to put that parenthesis there. It's 1, and then when I distribute the plus, it's 3i, correct? So then this becomes x plus 1, and then I distribute the plus sign, and it becomes minus 3i. So every single time you move a root over, if it is negative, the first sign will always become positive, because that's how you get it to move to the other side. The second sign, in a case of where it's a negative that's moving over, the second sign stays the same. But notice, when I say stays the same, I mean stays the same from here to the other side, from here to the other side. But when it does move over, do you see how the second sign is always going to be different? All right, the same thing occurs here, but when you are dealing with the negative, that's why it looks like it flips. If I have x equals 4 plus 5i, I also have x equals 4 what? Minus 5i. So guys, this is a positive root. When you move it over, what does it become? So when you do that, you're saying x minus 4 plus I. 5 plus. So what happens with this negative? So x minus 4 minus 5i. When you bring this one over, this becomes x minus 4 plus 5i, because you're distributing the negative. But don't get hung up on that. Get in your mind that when you bring this root over, the first sign will be the same, whatever it is. On the right-hand side, when you move it over, it becomes the opposite. If it's negative, it becomes positive. If it's positive, it becomes negative. And then your second sign should always be different. Why should they be different? Because when you multiply them together, what do you want the i's to do? Cancel out. So if you have a negative root to begin with, if it's a negative 6, a negative 4, a negative 3, when you move it over, that first sign is a plus. It doesn't matter. If you look at that and you're like, oh, I didn't change the first one to a plus, I changed the second one. It doesn't matter. As long as the second term has one positive, one negative. That's it. Just think of it that way. Yeah.
For reals, it would include like square roots, right? Because those are still real.
Yes. Yeah. Yes, ma'am. Question?
Oh, for like 1 and 2, when it's like the root of 2, why would you also write the negative?
Because if you don't, then they don't cancel out. And a polynomial function, by definition, it cannot have a square root in it. Like you can't have the square root of 2. That makes it not a polynomial function. So in order to make it a polynomial, you have to account for the positive and the negative, and then the roots will cancel out.
So we would do that for those and also do that.
For complex and for irrationals, yes. Anybody else on first page? All right, let's go to page 2. Let's talk about 2. I think for the most part, you guys are good with this stuff. You're going to have there's 9 questions total. I told you that. There's 9. There's one of those zeros things. There's one of the factoring things. Then you're going to have 3 or 4 of these that says, here is a rational. Find the holes if there are any. Here's a rational. Find the vertical and horizontal asymptotes. Here's a rational. Find a slant and horizontal. You know what I'm saying? Like, just specific things. You're going to do a lot of factoring. A lot of factoring. It's not a big deal. You guys can all handle it. When you have any of your slant asymptotes, guys, how do we answer our question? Y equals. If you don't write y equals, you're getting points off. It is a line. A line is written in y equals mx plus b. What do we do with the remainder? You just leave it. You don't worry about it. If you have a remainder, don't worry about it. You leave it. Do not include it with your answer. Yes?
Would you allow us to like use synthetic division on stuff like 12? Like you could just do -5?
Mm-hmm.
How do you want us to write our like a holes, like negative, like you want us to put
X equals.
So not coordinates?
You don't have to. Because I'm only concerned about the x part of the,
But for the graphing part, when they ask for holes, well, we're not gonna have.
you won't, mm-mm.
And then, are we gonna have one where it wouldn't factor out and we'd have to use quadratic? Or do they all factor out?
For what?
Like finding like the vertical asymptote or something like that. Or like, yeah, where you have to set it equal to 0.
Probably not. Sophia, question?
Oh no, you answered.
Okay. All right, let's scoot along here, guys. Graphing. Graphing. I want to go over some of these with graphing. You guys aren't going to have one with a hole. We talked about that. But are we okay with how to find everything? Okay, we're okay with how to find. This one was causing some people some issues. And I have to, guys, I cannot impress upon you enough. The first things you need to put on the graph are your vertical and horizontal asymptotes and your x and y intercepts. That will help you determine where your graph is. All right, what does your graph never, ever, ever, ever cross? The vertical asymptote. So get close to it, but don't touch it. If you cross the horizontal, I'm not going to make a huge deal of it because some of them do, some of them don't. But you guys don't have your graphing calculator, and I'm not going to have you spend a million minutes trying to just find points. You need the general direction and the shape. Remember, if you have something that has a middle section, it's either going to be a parabola or a snaky looking thing. So you need to pick points in between the vertical asymptotes to the left and to the right of the y-intercept to see what kind of shape the graph is going to make. I did buy color pencils, so I will have them here for you guys to use, so it's easier for you to graph, and it's easier for me to see it. So you don't have to worry about bringing anything. I think about like 200 or something like that. Okay, you also will have, guys, a question like this. Everybody will have a question like this, and every single time the question will work out exactly like this because you are given the complex root. So the first thing you're going to do is write the complex 0 and its conjugate. They're going to give you one of the zeros. You have to say, oh, okay, I also have this one. You multiply them together. Then you're going to use your long division, and you will not get a remainder. If you do, don't raise your hand and tell me, oh, Ms. Meadows, there's a problem here. I'm going to say check your work. All right? There is a problem because you made a mistake. You've got to go back and find it. But you're always going to be able to factor the result, right? You can factor the result here, and then you will find your real zeros. Does everybody understand that? Look at the beginning. How many answers should I have here? 4. Well, at the beginning, they gave me 1. Then they also gave me 2 because I have to account for the conjugate. And then you find the real ones. All right, again, I wanted to go over just in case you have an issue where you get an imaginary in your denominator. What does that say about your domain? And what does that say about your vertical asymptotes? There's no restrictions. All right, you're going to write your domain in interval notation from here to here and here to here. Make sure it is chronologically correct. If your two asymptotes are -3 and 7, don't tell me it's -infinity to 7 and then -3 to 7. What? Write it in order. If you need to write it on your number line, write it on a number line. Do that. Mm-hmm.
For the domain, if there's a hole, we don't include it, right?
No, because I'm not asking about holes. Like, I'm giving you a problem and I'm saying here,
All this domain is
where do you look for domain? But where? Numerator or denominator? To worry about just the denominator. I'm not going to throw something at you that has a hole that you have to then account for it. I'm not going to do that.
Saw a thing like on the other one that we did where there was a union and the number was just on its own.
You have to tell me exactly what you're talking about.
It was the second, graphing one.
Right, because there's a hole.
Yeah, so then we would just,
Right, but I told you guys you're not going to graph holes. Like you're going to have a question that specifically says, here, identify the holes. So how do you do that? I'm trying to figure out if you know the mechanics on how to do it. How do you find the holes? Factor, numerator, denominator, see if anything cancels out. If it does, set that equal to 0. Yeah.
so it's not gonna be like one of those like long ones where the holes are included, like,
You're going to have one of the long ones, but you're not going to have a hole. Vertical asymptotes, yes. Could have slant asymptotes, yes. Could have horizontal asymptotes, yes. But you're not going to have holes. And then this is just what we went over yesterday. So does anybody have any questions? Anything you want me to look at? This is on the review. This is it's already posted. This is on the review. It's in the answers. Do you guys have anything you want me to go over? Which thing? Like what about it? The fact that the domain is negative infinity, positive infinity? Okay, because think about it. If you have x squared plus something and you set it equal to 0, right? So what this is saying, if you get an imaginary solution, the reason your domain is negative infinity to positive infinity is because there is no value for x that you could plug in that would make your denominator 0. Any positive number, you're going to square it, multiply it by 4, and add 81, right? Any negative number, when you square it, it becomes positive. You're going to multiply by 4 and add 81, and if you put 0. So there's no domain restriction. Nothing will make the denominator 0. Yeah. Guys, what if you don't have, what happens if you work out, like say, this came up yesterday. This was a good question. Say this was your function. Hold on, I gotta think for a second. So f of x equals, right, 6x plus 4 over x squared minus 3x. And I say, find the y-intercepts. How do you find y-intercepts? Okay, 0 into everything. So 6 times 0 plus 4 over 0 squared minus 3 times 0. 6 times 0 is 0. So I have 4 over what? 0. What does that mean? There's no y-intercept. It's not 0. If you have 0 in the numerator, yes, your graph is going to cross at 0. If you have 0 in the denominator, that means it's undefined, so that then it tells you there's no y-intercept. Does that make sense? Okay. All right. Yep. Wait, say it again. I'm sorry.
What happens if you have a numerator and a denominator?
In 0?
Yeah.
Then it's just 0. Then it crosses at 0. That's fine.
Is that the same for x intercept?
Yes. But yeah. Correct. Okay, so here's the horizontal asymptote. Let's talk about when you have a horizontal asymptote. Let's talk about, this is a good review. So numerator, denominator, numerator, denominator, numerator, denominator. There's 3 different situations, right? When the numerator degree is greater than the denominator, when it's less than, and when it's equal to. All right, so think about this. Let me show you what this looks like. If you have x cubed over x squared, do you guys agree with me that the numerator is bigger than the denominator? So you would have no horizontal asymptote, but yes to a slant asymptote. Think about that, because with slant asymptote, you use long division, right? How many times can x squared go into x to the third? 1x times, right? Okay, so that's the only time when you have no slant, when you have no horizontal, you will have a slant. It's when the numerator degree is bigger. In a case where it's less, this would be like x over x squared. Right? 1 is less than 2, so y equals 0. That's your horizontal asymptote. Your slant asymptote is none. Why is it none? Well, think about it. If you're going to divide, how many times does x squared go into x? It would be the square root of x, right? We don't do that. That's not going to be a line. And then when you have equal, so like 4x squared over 5x squared. Your numerator degree is the same as the denominator. So what's your horizontal? Y equals numerator over denominator. And you do not have a slant. Because think about it. If you were going to divide, how many times does x squared go into x squared? How many times? Huh? Once. Is that a line? No. It's gonna. If you're gonna have a slant asymptote, you're gonna have something x or just x or something. It's gonna be written in y equals mx plus b. So make sure you guys are paying attention to that. I mean, we spent a lot of time on this, guys. I think you're gonna be okay. Yeah.
For the graphing where it's like x-intercepts,
Mhm.
y-intercepts, we plug those in to help us gauge where it's gonna be, but we still have to plug in, we have to find a point.
Sometimes you do, sometimes you don't.
So like, what do you mean?
Like, what happens if I go back? Okay, here's a good example of what Alec was just asking. Okay, so in this graph, do you guys see, this is number 17, but your vertical asymptotes are at 0 and 5. That's the mint color. Then you have your x-intercepts at +2 and -2 on the x-axis. Do you guys see in purple where I have the +2 and the -2? Yeah? Now, the y-intercept is what? What's your y-intercept here? What is it? There's none. It doesn't touch the y, okay? So, in this case, I knew that this boomerang existed down here because why? Where is the intercept? It's going to go through the intercept always. So, it's not going to be up here and not go through it. But what you guys have to then determine, like over here, I didn't know where it was. I didn't know if it was top or bottom. So, I picked a point to the right of the vertical asymptote. And then once you pick that point, you figure out, okay, when I plug it in, about where is the y value? Is it above the horizontal asymptote or is it below? Same thing in here in the middle. I had one intercept, but I didn't know if this was going to make a parabola or a snaky thing. So pick a point to the left, pick a point to the right. You guys cannot go wrong with picking points and plugging in. If you get to this, I would personally, I would do the entire test. I'd do all of this, the mechanical part of this question, and I would come back to the graphing at the end. Make sure you get everything done so you're not like stuck on this, and then if your version has 3 questions after it, then you're like, oh, I didn't get to it. Like, do all of the mechanical stuff, and then do the graphing at the end. So then you can take your time picking points and stuff like that. Santiago? Sure.
How many points is the graphing worth?
I have no idea. I mean, it's not going to be worth like 20 points or something like that. There's only one graphic, yeah.
So we got like all of the actual like work right, and we got like some on the graph wrong.
You'll be all right, yeah. Because again, you guys are doing all this by hand. So a really important part of it is that you graph your vertical and horizontal asymptotes correctly, that your intercepts are correct, that sort of a thing. Anything else?
Can we go to number 15?
To number 15? Yeah, hang on. Sure. Okay, question on 15. All right, do you guys see your vertical asymptote? That's right here in blue. All right, that's your boundary line that absolutely will not be crossed. Slants and horizontals, they sometimes will cross, but there's still a boundary line. So I know that my boomerang is going to exist on the right-hand side of my asymptote at least here and here because of what? Because of intercepts, okay? Well, that point I plugged in. But because of intercepts. Do you see this intercept right here? This graph is crossing right there. Then again, I knew that this intercept here is going to cross there. So you use your asymptotes as boundary lines. Once you figure out, if you wanted to, Eva, you could say, okay, let me plug in where x equals here, where x equals here, and you can get a better idea of if the graph goes like that or something. But you have to, the general shape, you need to base it upon your intercepts and then the asymptotes as boundaries. Sure. So you have, hold on, you have like a vertical asymptote up and down, right? So you're going to pick points to the left and to the right. It's not going to touch there. But if your intercept is here, your graph is not going to come this way. It's not going to do that. But again, you know that by plugging in points. Plug in a point here and plug in here and kind of see the general shape. If you're not 100% sure, plug in a couple of points. It's not a big deal. And it'll give you a better idea of the shape of your graph. But just plug in a few on the left-hand side, a few on the right-hand side, and just kind of see the general area. Is it, you know, there's a big difference between if your y value is positive 6 or if it's negative 6. Then you know where the graph is going to touch.
How would it be on the opposite way? Like if this is positive 6, how would it be for negative 6?
Well, if you plugged in, say you plugged in negative 3 and got negative 6, it would be down here. Use,
So it doesn't cross that.
no, use your asymptotes as boundary lines.
And then the other side.
Correct.
It could be a graph too.
Yeah. Just depends upon what your function is. That's why you plug in points to kind of see where it is. Yeah.
If we're given like all the intercepts, like that might help us like already graphing, do we have to add any extra points?
If I plugged in -2, like why wouldn't a boomerang be there?
If you plugged in negative 2,
Yeah.
the point would probably be along this line somewhere.
But like why is there like why doesn't there have to be like a boomerang like anytime like the vertical on this side? Like you see like the little triangle?
Like, no. Just because there's a space there doesn't mean if you plug in negative 2, it's the value of y is going to be up here somewhere. It's not going to be in here, and that would show you, oh, it's going to be here. That's how you know where to put the boomerang. Plug in -2, -5, and -8, and then just see, and it'll show, and then just connect them. It'll show you exactly where it is. You guys are going to be fine. All right, say this was an answer that you guys got, and you're asked to write it in different ways, over the reals, over the rationals. The zeros, if it says zeros, and the factor completely go hand in hand. All right, you just go backwards. You put it in a parenthesis. Factor completely and zeros go hand in hand. Then you have over the reals, and then you have over the rationals, irreducible. All right, so if you look at this initially, if I set this equal to 0, I'm going to get an imaginary. If I set this one equal to 0, I'm going to get a real, but it's going to be what? Irrational. It's not pretty. You can't say, okay, this is exactly where this lies on a graph. And then the last one that I have, I'm going to get a real and rational. Just because it's a fraction, no big deal. It's a terminating decimal. It's going to be 3/4. So if you're going to factor completely, you set everything equal to 0 and solve it. So I would get here x equals plus and minus I root 5, because we'd move 5 to the other side, take the square root. Here, I would have x equals plus minus square root of 11. And then here, I would have x equals negative 3/4, okay? So if you are to find those zeros, found them all, there's 5, and then put it into parentheses. This would be x plus I root 5, x minus I root 5. X plus the square root of 11, x minus the square root of 11. And then your 4x plus 3. That is factored completely. That's taking your zeros and just moving them in over the equal sign and into a parenthesis. Now if it says you want irreducible over the reals, that means you still break down the reals, but what do you condense? What do you smush back together and not break down? The imaginary. So you would keep x squared plus 5 not broken down because it's not a real fact. It's not a real solution when you get there. But you would leave x plus root 11 and x minus root 11 because those are real solutions. They're just not pretty. If it was over the rationals, that means you do not break anything down that's not real or pretty. So you would keep x squared plus 5 smushed together. You would keep x squared minus 11 smushed together. And then you would have your 4x plus 3. Do you guys visibly see the difference between, this is one question, can be asked 4 different ways. I can ask you for the zeros. I can ask you to just write the factors irreducible over the reals, over the rationals. You've got to pay attention to what it's saying. So over the reals means break down everything that is not imaginary, whether it's pretty or not. Over the rationals means only break down what's pretty. Does that make sense? A little bit.